Hello everyone, welcome to another video. So in this video, we will continue from where we left off in the previous video. So in the previous video, you can find it in the playlist. We containerized or dockerized our customer management application. In this video, we will be trying to run the same application from within a Kubernetes cluster. So for running it locally, we will be using minikube. If you haven't watched the installation video, you can refer to that. It will be available in the cards somewhere at the top. Yeah, so assuming that you have already installed minikube in your system, so let's proceed on that. So let's open up the code base. So here was our customer management app, uh, which we were running locally as a Docker image. Let's see. So this is the image that we were creating earlier. Now let's see how we can run that in Kubernetes. So first thing, we need to start our minikube. For that, I use this minikube start. So as you can see, this is starting the minikube within my host OS. And this actually, for me, I used a virtual box. So minikube utilizing virtual box here. Okay, this is started. Now let's start the minikube dashboard. For that, we will be giving the minikube dashboard command. So this should open up a browser with the dashboard view. Yep. So here we can see this is the dashboard view. We can see the pods. As of now, there are no pods. We can see some namespaces here. Okay, services. So default Kubernetes services are running. Okay, looks good. Now let me quickly open one more terminal here. Okay, so what we are going to do is we will be deploying our application in Kubernetes. So for that, uh, we would have to first get into the uh, shell of this minikube, like the Docker environment of this minikube. So for that, there is a handy command here. So if we use this eval minikube Docker environment, so it actually now points to the Docker environment of the within the minikube. So if I run Docker images now, you should see these are the images which are available within these are all Kubernetes images. So these are all coming from within the minikube. So this is different from, let's say, if I just open a terminal and if I just give Docker images, so this list is different from the one below here, because the one that you see in the terminal here at the top is my host OS Docker. So till now we have our Docker images in the host OS Docker. Now we have to build the images within this minikube container. So this is required because we are trying to do that, trying to build it offline. So there is one more approach, like if you publish your Docker images to Docker Hub with the proper username and ID. So you can download it from here, but we don't want to go that route because it will be very slow. And for uh, quick resolution, we would be going for a local build. Okay, so for the first step is we have to create the Kubernetes config files. So for that, let's just create a directory first. So let me just create a directory with this name. Helm. I'll tell you why I created this Helm template. So even though in this video we are not going to cover the Helm charts and all, but this structure will help us in future. So it's not mandatory as for this particular step to create this folder structure, but we are creating it in future, as we know that we'll be using Helm charts. Uh, so we are creating this. Let's create this YML file, which will be our Kubernetes config file. So now let's head over to Kubernetes documentation here. So first thing is a Kubernetes deployment. So I'll try to give this link in the video description so that you can refer to there. So this is a sample deployment config given for Nginx. So let us just copy paste and modify it according to our needs here. So let's just, so deployment, the name, so let's give it customer dash management deployment, app name customer dash management, replicas. Let's start off with 3. We will play around later. Again, app customer dash management. Okay, I should copy this one. Image. So as you know, our image last time we built with this convention customer dash management colon latest, which is the latest tag. Port number, we are gonna have it on 8080 because as you can see in our application.yml we have given this port 8080, so that's why we are giving it here 8080. Container port. Okay. One more thing I would like to add over here is image full policy never. So why we are giving this additional thing is like there are options like, so if we don't give it, so if it finds while executing this script, if Kubernetes doesn't find the image, which is basically the customer management colon latest image in the local Docker repo, it will try to connect to Docker Hub and try to download the image. But this line, it mentions that never download it from Docker Hub, because we know that for this tutorial purpose, we are going to always build it locally. So that's why this tag. And we have also have to pass some environment variables. Yeah, so env. Let's give. So this is the syntax. If it looks a little odd, I would suggest have a look at the Kubernetes documentation. So we are just giving an array of key value pairs as an environment variables. So the value will be, we'll give the value later. And then we have the, let's copy it from this application. So what were the environment? This one is done. DB port value, it will be 5432. Let's just copy. Okay, now what is this? PostgreSDB. This is PostgreSDB. Then we have Postgres user and Postgres password. Okay, so DB port, DB, this is common for us. Okay, this looks good. Now the DB host parameter. So this will this value will be the IP of the Postgres server. So we will deal with it a little later. So for now, because we haven't yet installed the Postgres within the minikube, so let's move on. We'll fill it later. So we need to create some create a service also to access it. So a service in Kubernetes is a logical abstraction over a, what we can say is like if you have multiple pods, like multiple instances of the application. Service is kind of an abstraction. It gives you a one point of contact for all the instances. So again, for the service, we will head over to this Kubernetes reference doc. There is one example given here. Again, I'll try to give this link in the video description. Let's just copy paste and change the name for our, so this is customer dash energy management service, copy app. Yes, so this app selector should match with this one. Where is the app? Yeah. And TCP port. So we would be giving this port as 8080, which we have configured at the top. Also the target port. What? Oh, HTTP. For now, let's just skip the HTTPS. Later we will decide. So TCP port is 8080. Target port is 8080. And we will configure one more thing, which is node port. So let's give it a value. So what is this node port? So the node port, okay, let's go one by one. So what is this port? So the port is the port at which the container inner to the application is executing. Target port is any external application which will connect to this particular application via this port. So we have kept it same. And node port is if anything from outside the Kubernetes cluster, if some application is trying to connect. So this is the port it will be using. So we have given it a 32001. So because we will, while testing, we will be using Postman, which is outside the Kubernetes cluster. Okay. So, and one more thing which I would like to add over here is a type. So we would like to give it a load balancer here. So we want, because if we have, let's say, more than one instance of this thing, which we can easily do it by modifying this value, replicas value, we can give 3, 5 or anything. So this would act as a load balancer. It will distribute the request to each of these instances. So there are different types of load balancers available. We will get into it detail later, not in this particular video, like L4, L7, ring hash and all. Okay. So this is a Kubernetes configuration file. Now let's just, so we have already executed this command eval this thing, a minikube Docker environment. So let's get started with installation. So first thing we may need is we don't have a PostgreSQL installed within this minikube. So last time we used this command to install the Postgres in our host operating system. Now let us just install this one within the minikube. So this would be downloading and it will take some time. Once it is okay, so what this says is it's not able to connect. Okay, so I was having some issue connecting to my ISP, so it was giving, so at this particular moment for some reason my internet was not working. So what I did is, like, I already had another version of Postgres configured here, so this one, so I just used this one because that was available locally. So I, instead of the Postgres which is available in Docker Hub, I just use some other version of Postgres. This is the one. So I think, but if you have a proper stable internet connection, it should not be a problem. So this is the one. Let me just quickly check if this is running or not. So yeah, this is up and running. Now what we can do is, like last time we did docker inspect to get the IP of uh, the Postgres. So this is the IP. So for now, for starting, we can actually copy this IP and put it over here. So in the DB host value. So this should connect to the Postgres. And yep. So our Kubernetes config file is ready. We have already started this minikube server. We can see the minikube dashboard here. What I prefer to do is, like we uh, I try to do any kind of demo or test things in a separate namespace. So let's just first create a namespace. So namespace in Kubernetes is something like that of a package in Java. It's just a uh, like in Java, if you have a clashing names, so the namespace gives you a uh, uniqueness about a particular class or an object. So here also, namespace helps in resolution. Like if you have same name of application, so the namespace is, if the namespace is different, then it will treat it as a different application. So let's just create one. So the command will be kubectl. So in Kubernetes, any command start with kubectl. Kubectl create namespace. Let's call it demo. Okay, so namespace created. So we can verify it. We'll go to this dashboard, click on this thing. Okay, we can see that this demo is created 7 seconds ago. Now let's just create or configure this configuration file. Let us just execute this. Kubectl create -f. What is the folder structure? Templates, customer, and we want this to be within this demo namespace. So what I've given is kubectl -n demo is -n a shortcut for namespace. Then create this thing. Okay, created. Let's just verify. At the top in this drop down, it will filter by namespace. So I selected demo, and let's see the pods. So there are some issues. Services. Okay, service is there. So we can see the logs from here. Okay, so sorry, the image is not available. That's good because we haven't built the image yet. So for building this customer management app image, last time we build it using this command. So but that was within the host Docker. Now we have to do the same thing within the minikube Docker. So let's just see, we are in the minikube environment. Let's just build it again. So it is building. Okay, it took some time, but it did build the image. Thing, select already authenticate, open JDK, this, yeah, it has done. Let's check it by running Docker images. So yeah, this image customer management latest is already available. Now let's execute this Kubernetes create once. Before that, let's just clean the older ones which were failing. So the command is this, just replace delete in place of create. Now let's execute this again. Let's check the pods. Okay, let's check the logs by clicking it here. So we can see that app started. Let's check the service. You can see services should also be up and running. We can also check the service via this command kubectl get svc, which is short for service, and -n. We want to only see this one. So the service is up and running, and this 32001 is the port, node port, where we can try to connect to. Let us just verify this thing in Postman. Uh, so font size in Postman, I'm not sure how to increase. Let's use a browser to just check the alive. Remember that we created one API just for this purpose. Here, this alive. So let's just test this one, whether this returns properly or not. So localhost. Oops. So earlier we were using localhost for that one. Now, one thing we need to use over here is the IP. So it's not running on localhost. So it's running within minikube. So first we need to get the minikube IP. So for that, this is the command minikube space IP. The IP is 172.170.2. So we got it 170.2. Then port number is this port number which we have configured here in the service node port. This is what I was mentioning earlier. So this 32001. So we gave 3/customer. We should get an alive if it works properly. So I got something else. I think the image probably is a little old. So let's just clean the images. We are getting alive, but I think along with it something else. So let's just build this one. Build our project. Radl w clean build -x test. I was just trying a few things, so that's why some extra text is coming. We'll also do that thing, but let us just go slow. So the latest image is built. Now what we need to do is delete this one and again create this one. Created. Let's see if we can get it. It's not up yet. Let's just check the dashboard once. Pods. They should be up and running. Still giving alive. Oops, I forgot to build the Docker image. This happens. Okay, so we are building the Docker image. It may take some time. Docker image is built. Now let's again delete and recreate. This is done. Okay, here we go. So let's just see. Yeah, we are getting the value. Now also we should be able to check this one in the logs. Yeah, the server is started, and now let's check the services. Here is the service config. This is up 29 seconds ago. Looks good. Okay, now what? Now what I was actually doing earlier was like now let's add some replicas, like more number of. Till now we have only one instance, so which can be verified. If you go to the pods, you see there is only one instance. Let's use 3 replicas. So that means 3 instances of this application will be spawned. Let's just delete and create Now in the pod set, we should see three are up and one is getting deleted, right? Okay, cool. Now again we should get the same. I think we are getting it. Yep. Okay, looks good till now. How do we know whether that is load balanced or not? So let's just test it once. What I'll do is I'll just create a test class. Mm, oops, test rest template. Okay, we got the rest template. Now let's create a. So what I'm planning to do is like get the unique host name, or if you see here in this dashboard, each of these pods have a host name with a unique host name. So I would be appending this in the response in the alive and try to make a get call. So what I mean is in this alive, so I can actually do optional dot of nullable dot get env dot get hostname dot map. If we get the host name, then uh, just use the like this. This is alive dot or else return this one. Okay, yeah, looks good. So what we did over here is like if host name is available, then append the host name, prepend the host name with alive. Otherwise, just return the alive. So let's just build this app. First, do a Gradle build. By the time it gets built, let us use our testing code. So just give some host names equals to new hash set. Oops. Okay. I equals 0, I less than 1000. So what we are going to do is we will be firing 1000 get request and see what is the host name and set them in a set, so that because set stores only unique values, we should expect to see all the unique host names. So rest template dot get for entity, let's give the URL is this one, and return type is string dot class dot get body host names dot add. Yeah. So we are firing a get request at this URL. We will get a response, add it to the host names, because this is a set. Duplicate ones will not be stored, and once this is done, we are going to output the host names. Okay, so before that Gradle build is done, now we need to do a Docker build. Note we have already used this command, so I'm not explaining these. So it will take some time. I'll pause it and come back. So the Docker build is also done. Now let's deploy it in Kubernetes. Delete, create, done. Now let's just check. The pods are coming up. Okay. Let's just see. Still giving old values. Not sure why. Did we make the change? Yes, alive. I think this is, we are not getting the exact value. Let's check. what we can do is Google. Let's just search what is the exact thing. System.get environment of, okay, this is what we should be doing. So, okay, I did it. I'm not sure if, so we have to go through the, unfortunately, we have to go through the all the steps again. Gradle build, then Docker build, then deployment of Kubernetes. In future, we will be doing it via scripts, shell scripts. So just bear with me for now. This is done. Now do a Gradle Docker build. Docker build is also done. Let's redeploy in Kubernetes. Okay. Okay, so now we are getting this thing. So I believe this is one of the 7F5. Okay, first one. Okay. Now, if we with this test class, if we run this enough number of times, we should be able to see, like, it should route the request to each of the load balancer should route the request to each of the nodes. So let's run this one and see what we get. We expect to see three items in the set. So here is the 1, 2, and 3. Yep, looks good. So these are the ones: 7F5 something, JBQC, XDWM, and S928C. Let's just cross check. JBQC, S9, yeah, looks good. So it is actually distributing the load between these three instances. Okay, now let's try the DB connectivity once. So what we'll do is we'll just open up a new window, try our usual post and get. So let's create a post request quickly. Application JSON, let's copy something. Okay. Oops. Copy, pay. Why is it not copying? Okay, so let's just use something. Okay, we get an ID 2. Now let's use a get request to retrieve that one. /2. Yeah, this is hitting this service. So we are getting this 2. It looks good. So we can actually see that we are hitting this service, this customer management service, and it is routing the request to one of the pods, and we are getting a response from there. So in this video, we found that we were able to deploy our code, which we in the previous video we did it containerize it. This time we are able to execute it within a Docker within a Kubernetes cluster. In the upcoming videos, which is as per the plan, we will try to deploy the same thing using Helm charts. So till then, stay tuned. Bye bye.